So question number 1. Make sure I've got my pen. Determine whether the ordered pair is a solution of the system of linear equations. So for this, you want to take your ordered pair 6, negative 5, and you want to plug it into each equation, and it needs to be a true statement in order for both of them to be a solution for the system. So if we've got 6, negative 5, the 6 is your x, and the negative 5 is your y. So you want to plug these values into each equation. So we'll start with the first one. So we have 4 times 6 equals 19 minus negative 5. So 4 times 6 is 24 equals 19 minus negative 5 is the same thing as 19 plus 5. And then 19 plus 5 is 24. So we do have a true statement for the first equation. And then for the second equation, we're going to plug in the same ordered pair and see if we get a true statement. So it'll be 3 times 6 equals negative 2 minus 4 times negative 5. So 3 times 6 is 18 equals negative 2, negative 4 times negative 5 is positive 20. And then negative 2 plus 20 is positive 18. So 18 equals 18. That's a true statement as well. So this solution, this ordered pair, 6, negative 5, it is a solution. So the answer here would be yes. Okay. So question 2 says, solve the system of equations by the elimination method. So the elimination method means that we want to eliminate one of our variables by adding the equations together. And so if you look at your equations, and see, I hope you can see that. Let me see, make sure you can see that. Well, I'll make that bigger. Okay, so we've got 3x plus 2y equals negative 7, and then 4x plus 5y equals negative 7. So I'm going to rewrite it big here so we can see it a little better. So basically, you decide which variable you want to eliminate, and it really doesn't matter. It's all up to you as the person solving the system. So I'm going to eliminate x. That's just my choice, doesn't matter. So I want to focus on my x terms. So I want to multiply each equation or one of the equations by some number that will cause for my x terms to be opposites of each other. So to do that, I'm going to multiply this entire equation, the first equation, by 4. And then I'm going to multiply the bottom equation by negative 3. So let's see what happens if I do that. So for the first one, if I distribute the 4 with every single term in the equation, I'm going to have 4 times 3x is 12x, 4 times 2y is 8y, and 4 times negative 7 is negative 28. Okay, let's do the next one. What happened to my equation? Whoa, that's weird. Okay, so now let's do the next one. Negative 3 times 4x is negative 12x. Negative 3 times 5y is negative 15y equals negative 3 times negative 7 is positive 21. Okay, so now I'm ready to add my equations, and let's see what happens. So if you notice, if I add going down, let's look at what happens to my x values. So I'm going to add 12x plus negative 12x is no x, 0x. So So that's gone. That was the whole point of doing that. 8 plus negative 15, different signs. You subtract the sign of the larger number. That's going to be negative 7y equals negative 28 plus 21. Different signs, you subtract the sign of the larger number. It's going to be negative 7. And then divide both sides by negative 7. And so y equals positive 1. Okay, so that's half of my solution. Let me get the other half. So I'm going to take my y equals 1, and I'm going to plug it into either equation. It doesn't matter. So I'm going to choose the first one, just because. So I'm going to rewrite that first equation again. 3x plus 2y equals negative 7. I'm going to plug in 1 in for y. And let's see what happens. So we have 3x plus 2 times 1 is 2 equals negative 7. And then I'm going to subtract 2 on both sides. So I'm solving for x. So I have 3x equals negative 9 divided by 3. So x equals negative 3 because negative 9 divided by 3 is negative 3. So that's one half of my solution. This is the other half of my solution. So the entire solution, the ordered pair, would be negative 3, comma, 1. That would be my answer here. Okay? And so notice your test review, the format looks so much like your actual test. So you want to enter your answer here. The first block, you put your x coordinate. That would be negative 3. And then the second block, you would put your y coordinate. That would be 1. Right? Okay. So the next problem we're going to solve by using the substitution method. So for the substitution method, you want to make one of your equations equal to a variable, isolate one variable. And if you're lucky, one of them is already isolated, which is the case here. So we have x equals 2y plus 8 and 3x minus 6y equals 4. So we actually already have an equation that is solved for a variable, and that's x. So we're going to take what x equals, 2y plus 8, and then plug it into the other equation. So I'm going to have 3, wherever I see x, I'm going to put my 2y plus 8. So I'm just going to set it up. So 3 times 2y plus 8 minus 6y equals 4. So then here I'm going to distribute. 3 times 2y is 6y. 3 times 8 is 24. Bring down my minus 6y equals 4. 6y minus 6y combine like terms, 0y, that actually cancels out. So we have 24 equals 4. So whenever this type of thing happens, that's not a true statement. 24 definitely does not equal 4. So when this happens, when you're solving the system, you stop right there. That means there is no solution. Okay? So there's nothing else you can do. And so notice for your test, pay attention to how you enter your answer. Enter DNE twice for no solution. And then the infinity symbol twice if you're trying to say infinity or infinite solutions. So that means if you were taking this test, you would need to type in DNE, DNE. That's how the computer is going to know that you're saying there is no solution to this system. Okay? All right, the sum of one number and a second number is negative 72. Twice the second number subtracted from 4 times the first number is negative 94. Write 2 equations to represent this system using x for one number and y for the second number. Okay, so let's set this up. Okay, so the one number or the first number we're going to say is x. Okay, and then for the second number, we're going to use y. So let's see the sum. So sum means we are adding. So the sum of one number, which we're saying is x, and the second number, which is y, is negative 72. That would be equals negative 72. So we already have our first equation for our system. Now, twice the second number. So, twice the second number is going to be 2 times, I'm going to write on the side, 2 times the second number is y. So that's twice the second number. Okay? Subtracted from. That's super important. Subtracted from means that we're going to take 2y away from something else. So it's going to be something minus 2y. Okay? So something's going to go in front of this negative 2y. Don't know just yet, but I want to just kind of set that up for you. Now, twice the second number subtracted from 4 times the first number. So 4 times the first number is going to be 4 times what? X. Good. 4 times x. Is negative 94 equals negative 94. So we've got our system now. We've got x plus y equals negative 72, and then 4x minus 2y equals negative 94. So one number is 2 less than a second number. Okay, twice the second number is 2 less than 3 times the first. Write 2 equations to represent the system using x for one number and y for a second number. Sorry, my handwriting is so messy. I'm just trying to write it out so I can answer it. Okay, one number is x. X is 2 less than a second number. X is, so that means equal to 2 less than a second number. So that's going to be, the second number is y, so y minus 2. So think about it like this. So one number is 2 less than the second number. So if the one number x was, say, 10, 10 is 2 less than the second number. That means the second number would have to be 12, right? So x equals y minus 2. That's that first statement. One number, x, is 2 less than a second number, so y minus 2. Now, twice the second number, so 2 times the second number is, remember, is equals, is 2 less than, so the same, something minus 2, 3 times the first, so it's x. So it's going to be 3 times x minus 2. So twice the second number, 2 times y, is 2 less than 3 times the first. So this is going to be your system here. All right, so long division. So we are going to start by putting our divisor on the outside of the box and make sure that you don't have any terms missing. So it goes from x to a constant, so we're good there. And then in the division box, we're going to put our dividend. So it starts off with x to the third. So we have x to the third, x squared, x, and then the constant. So we don't have any missing terms. So missing term would mean if we had like x to the third, and the next term was just an x. But we don't have any missing terms, so we're going to go straight to, okay. So you're going to take the leading term and the divisor and divide it into the leading term and the dividend. Negative 4x times what would give you negative 12x to the third. So, or what you're basically doing is that you're saying negative 12x to the third divided by negative 4x. That's what we're doing first. I'll put that in blue. So, negative divided by negative gives you a positive. 12 divided by 4 is 3. And then x to the third over x is x squared. So we're going to put 3x squared here. And then that's correct because when you take your quotient here and multiply back this way, you should get your starting term. So 3x squared times negative 4x is negative 12x to the third. If that doesn't happen, that means you did something wrong. Okay? And then we're going to take that 3x squared times negative 1, which is negative 3x squared. And then your exponent should also be in line 2. Now, once we do that, we're going to subtract everything. Okay? And you're basically changing the sign. So negative times negative, this becomes positive. Negative times negative becomes positive. So if you want, you can go ahead and just change the signs. So when we are ready to subtract, we just change all of the signs because we are subtracting. So negative 12x to the third plus 12x to the third cancels out. That's what should happen. And then negative 9x squared plus 3x squared is going to give you negative 16x squared. And then we're going to bring down negative 24x. And then we're going to go back and take the leading term in this dividend divided by our leading term in the divisor. So we're saying negative 16x squared divided by negative 4x. Negative divided by negative is a positive. 16 divided by 4 is 4. Then x squared divided by x is x. So we have positive 4x. Okay, then now we're going to multiply. 4x times negative 4x is negative 16x squared. Remember, that's the goal here. You should get the same terms. And then 4x times negative 1 is negative 4x. Now we're going to subtract. So remember, we're just changing the signs. Multiplying everything by negative, which changes the sign. So we're going to subtract, and then we're going to combine vertically. So negative 16x squared plus 16x squared cancels out. Negative 24x plus 4x is negative 20x. Then we're going to bring down that plus 5, and then we're going to go again. So negative 20x divided by negative 4x. Negative 20x divided by negative 4x. Negative 20 divided by negative 4 is positive 5. X divided by x cancels out. So we have positive 5. And then we're going to multiply. 5 times negative 4x, negative 20x. 5 times negative 1 is negative 5. We are going to subtract, so we're going to change all the signs. So when we combine vertically, negative 20x plus 20x cancels out. 5 plus 5 is 10. 3x squared plus 4x plus 5. And the remainder is 10 over the divisor, negative 4x minus 1. So this is how we write it if we were actually writing on paper. 3x squared plus 4x plus 5 plus 10 over the divisor. But remember, the remainder is actually this number here over the divisor. 8u to the fourth plus 12u to the third. Now it goes straight to negative 2u. I need to put a plus 0u squared there. Now I can put minus 2u. So I have to put that 0u squared to fill in for that missing term. Okay, so now I'm going to take 8u to the fourth divided by 2u squared. So 8u to the fourth divided by 2u squared would be 4u squared. And then I'm going to multiply. So 4u squared times 2u squared is 8u to the fourth. And then 4u squared times u is 4u to the third. Then I'm going to subtract. So I'm going to change all of the signs and then combine vertically. So 8u to the fourth minus 8u to the fourth cancels. And then 12u to the third minus 4u to the third is 8u to the third. And then bring down that 0u squared. Okay, so now we have 8u to the third divided by 2u squared. That'll be 4u. So that's positive 4u, and I'm going to multiply. So 4u times 2u squared is 8u to the third. And then 4u times u is positive 4u squared. See how that 0u squared is helpful there. Now we're going to subtract, so we're changing all the signs. So when we combine vertically, 8u to the third cancels, and then I have 0u squared minus 4u squared, so that's negative 4u squared. And then bring down that negative 2u. And so now I'm going to divide again. So negative 4u squared divided by 2u squared. Negative 4u squared divided by 2u squared is going to be negative 2, and the u squareds cancel. Then I'm going to multiply. Negative 2 times 2u squared is negative 4u squared, and then negative 2 times u is negative 2u. Then I'm going to subtract and change all of the signs. And then when I combine vertically, negative 4u squared plus 4u squared cancels. Negative 2u plus 2u cancels. So there's a 0 remainder. So your remainder is 0 divides evenly. So your quotient is simply 4u squared plus 4u minus 2. Okay, so factor 162x to the third plus 750. Okay, so this is probably going to be a sum of cubes factoring problem. So let's just write out what that looks like. So that's a cubed plus b cubed equals, you do need to memorize these factoring patterns. That's a plus b times a squared minus ab plus b squared. Just for the sake of showing you the other one, difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. When you're memorizing formulas and patterns, try to find similarities so you're not memorizing them as totally separate things. So if you notice, not a lot changes here. So notice the placement of your a's and b's and the exponents does not change at all. The only thing that changes is your signs. So for a cubed plus b cubed, your signs are plus, minus. For a cubed minus b cubed, your signs are minus, plus. Notice this doesn't change for either one. So all you have to do is figure out what your a and your b is going to be, and then you plug it into your factor pattern. So if you look here, we got 162 and 750. They may or may not be perfect cubes, but you can figure that out by using your graphing calculator. To find the cube, to tell if a number is a perfect cube, if it's a number to the third power equals 162, see if you can take the cube root of it. You could be great and know all of your perfect cubes, but if you're like me, you probably don't know them all. So if you go to math, this fourth option is the third root option. So I just go down to this here, and I put 162. Notice that I did not get a whole number, so that tells me that 162 is not a perfect cube. But that doesn't mean that you can't do this factor pattern, but you may have a GCF to factor out. So, and also 750, you can check 750 if you wanted to. The third root of 750. Again, 750 is not a perfect cube, but we probably just need to get a GCF. So you can use the calculator to kind of help guide you about what you need to do. So let's see. So a GCF between 162 and 750. So you can kind of just try different values. If I'm looking for a greatest common factor, I would focus with a smaller number because there's probably less possible factors to consider. So 162, we do know that 162 is divisible by 2 because it's even. So if I divide that by 2, I get 81. And maybe you'll see that 81 is in fact a perfect cube. Let's divide 750 by 2 and see if we get a perfect cube. And I do believe that we do. So let's see. If we take the cube root of 81, let's see what happens. Cube root of 81. No, not quite. And the cube root of 375, not quite. So let's try 4. 162 divided by 4. Okay, nope. 162 divided by, not multiply. Definitely not 5. Let's try 6. 27, okay. Let's see, 750 divided by 6. 125. I do think we have a winner. All right, so let me see here. Let me go back to my screen. I'm going to take the GCF out. My GCF is 6. When I factor 6 out, divide everything by the 6, I'm going to have 27 x cubed plus 125. All right. So now let's look at my new binomial, 27x cubed, and then 125. 27 is a perfect cube. 3 to the third is 27. Okay, and then 125 is a perfect cube. 5 to the third is 125. So let's rewrite it so we can see exactly what our A is and exactly what our B is, what's going to be our base. So I'm going to just keep that 6 hanging out on the outside. And so for 27, that's 3. And then the x is being cubed as well. So 3x quantity cubed equals 27x cubed. And then 125 is 5 cubed. So I'm setting it up to where I can use one of my factor patterns here. So I'm going to use this first one because it's a cubed plus b cubed. So your a is 3x and your b is 5. So let's go ahead and start plugging this in. So a plus b, that's going to be 3x plus 5 times a squared. Please be careful here. So many people just put 3x squared, but you were squaring all of a. So we're just going to write it like this for now. Minus a times b plus b squared. Okay, so now I'm going to say that 6 times 3x plus 5. And now let's clean this up. So 3x, all of that squared is going to be 3 squared is 9, and then x squared minus 3x times 5 is 15x plus 5 squared is 25. This is going to be our final answer here. All of this. Notice we're factoring, so we're not going to go back and multiply it all together. We're going to end up right back up with our original expression. Now let's look at using the graphing calculator to graph equations. And you can check, you can really solve all your systems using graphing with the graphing calculator. So it's something that is very valuable to know. Okay, so first off we have y equals negative 1/3 x minus 8/3. So to graph any equation in a graphing calculator, you want to go to y equals. Okay? And this is where you're going to put your equation. So in order to graph using the graphing calculator, you have to set the equation equal to y. That's the first step. Lucky for us, these are already set equal to y. So we're going to put in our first equation here. So I like to put my fractions in parentheses. It really depends on what kind of calculator you have. Some calculators will set up your fraction for you, but I don't think this one does. So I'm going to say parentheses negative 1 divided by 3, close parentheses, x. Okay, then minus parentheses 8 divided by 3, close parentheses. Now first let's just see how I would graph this one. So I'm going to say graph. And there it is there. Okay, let's do the other one. So I need to put another equation. I'm going to go back to y equals. I'm going to cursor down and then enter the next one. So it's negative 2/13x. So negative parentheses 2/13x minus 37/13. 37/13. You see how fractions are no big deal because you've got your graphing calculator. Now we're going to say graph and see what's going on. Okay, so we can clearly see that we do have a solution. Our lines are intersecting. That's really hard to see, and you don't want to have to try to figure it out by moving the cursor around. That would be very annoying and not accurate because who knows exactly where it is crossing. But the great thing is that your calculator will do it for you. So if you want to calculate, so this option here, you would say second, calculate, and you want to find where they intersect. So we're going to choose option 5. You either just press 5 or you could do the cursor down to 5. And so now all it's doing is asking you to put your mark over the first curve, which really is just your first line. So say enter. Now it's saying, okay, is this your second curve? It's basically asking you to specify the 2 lines or curves you want to find the intersection of. Because you could potentially have more than 2 lines or curves. So the calculator just has a default question of asking, okay, what's the first thing? What's the second thing? And then now it's like, okay, you want me to guess? And then you want to say, yep. And you press enter. And then it tells you exactly where it's intersecting. So this system is intersecting at 1, -3. That's your solution. 1, -3. So let's look at if you were graphing a linear inequality. So here we have 2x minus y is less than or equal to 6. Now for this, we're going to have to set it equal to y, which it is not set up like that yet. So I'm going to start that process. Okay, so we got to set this set equal to y in order for us to use the graphing calculator. So to start that process, we're going to subtract 2x from both sides. So now I'm going to have negative y is less than or equal to negative 2x plus 6. And then now I need to get my y by itself, so I'm going to multiply both sides by -1 to make my y positive. So I have positive y, I'm multiplying by a negative, so I have to flip my sign is greater than or equal to distribute the negative, positive 2x minus 6. This is what I'm going to put into my graphing calculator. Okay, so let's go back to y equals. Let me clear this out because I'm done with this problem. All right, so we're going to put in, so our equation was, I forgot. All right, so 2x minus 6, that's easy, right? Now if you graph it like this, that is just graphing the line. That's not graphing the inequality. It's y is greater than or equal to. So if you were shading that greater than or equal to, you would shade above the line. So you want to notice I cursored over to the left. So I go over to the left, and then you see where it's blinking here. If I press enter, I can get lots of different choices. I can have a really thick line. I can, this means I'm shading above. Notice the picture here. This means I'm shading below. Notice the picture here. If I press it again, I'm not sure what that is. And then if I press it again, that's for something else, I believe. That's for points. If I want the dotted line, it looks kind of dotted. That's how it would look. Or if I just want a regular line, that's how it looks. But it was greater than or equal to, so I'm going to shade above. So that is how my graph should look here. Graph, you can see that very clearly. So the answer here would be this first option here. And then to graph a system, you would do the same thing, but for two different inequalities. You would set them both, isolate y, then you would graph each one, and then you would use your options to shade whichever way you wanted to. Okay, I see one question. I'm going to do this one that I just wrote, and then I'll do the other question. So I'm going to factor this polynomial. So always check for a GCF first, which is the greatest common factor. Sometimes there is one to factor out, sometimes there is not. So you're looking for a common factor between 21, 18, and 9, which for these, there is a GCF of 3. 3 can be divided evenly into 21, 18, and 9. And then now they all three have x terms, and they have exponents. So you want to take the smallest number of exponents of x's they have in common. All three have at least 3 x's. So the GCF is 3x to the third. So if I factor that out, you're basically dividing everything by 3x to the third. So 21x to the ninth divided by 3x to the third is going to be 7x to the sixth. 18 over 3 is 6. X to the fifth over x to the third is x squared. And then 9x to the third divided by 3x to the third is plus 3. And then here you have a trinomial, but this is not factorable. So this is going to be your final answer here. Now I have a student question, which is asking to factor 125c to the third plus 64. We have two terms, so it's a binomial. So you have a few options. You either have difference of squares. It's either a squared minus b squared. It's either a cubed plus b cubed or a cubed minus b cubed. If you can't get it to look like one of these three, it's not factorable. Or if it doesn't have, or it has to have a GCF to factor out. So here there is no greatest common factor between 125 and 64. Okay? So first off, it's a plus sign, so it's definitely not one of these. And now you want to look at 125. Is 125 a perfect third, a perfect cube? Yes, it is. 5 to the third equals 125. Okay, what about 64? Is 64 a perfect cube? Yes, it is, because 4 to the third equals 64. So I'm going to rewrite this so that I can identify what my A and my B is. So I've got, this is going to be 5C cubed. You're basically taking the cube root of this to figure out what goes in the parentheses. And then here you're taking the cube root of this to figure out what goes in the parentheses. So now you can see that, let me use some colors here. This is your A, 5C is your A, and 4 is your B. So let's write the factor pattern. So it's A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. You do want to memorize that. So everywhere I see A, that's where I'm going to put 5C. And everywhere I see B, that's where I'm going to put 4. So I'm going to have 5C plus 4 times 5C squared minus 5C times 4 plus 4 squared. Everywhere I had A, I put 5C, and everywhere I had B, I put 4. And now I'm just going to clean this up. So that's 5C plus 4 times 5C squared is 25C squared. Negative times 5C times 4 is negative 20C. And then 4 squared is 16. So this is going to be my final answer here to factor that binomial. Factor, this says to factor by grouping, and it is 30x squared minus 18x minus 25x plus 15. So you actually could factor not by grouping because you can combine like terms in here, but we're going to use grouping because that's what it has for, and we can get practice doing that. So always first check for a greatest common factor between all these terms. There is no GCF here, so we're going to go straight to factoring by grouping. So to factor by grouping, we start by grouping the first two and the second two together. And then from each group, we're going to factor out the GCF for each one. So the GCF for this baby group is going to be, it is actually 6x. So when we factor that out, 5x minus 3, because 6x times 5x is 30x squared, and 6x times negative 3 is negative 18x. Now we're going to factor out the GCF for this guy here. Now, our goal is to get the same thing. We got 5x minus 3 here. We want to get it again over here. And then you always want to factor out this negative here. So it's going to be negative, let's see, they both don't have an x, so x won't be a GCF. The GCF here would actually be just negative 5. So we factor out negative 5. We're going to have left over positive 5x, then negative 3. Because negative 5 times 5x is negative 25x, and negative 5 times negative 3 is positive 15. And like I said before, the goal when you're grouping, you're trying to get the same thing here. If you don't get the same thing, I like to call them the twins. If you don't get the twins when you're factoring by grouping, something's off. So once you have that, you just write down the twin, so write one of them, and then whatever's left over on the outside comes together in your other factor, 6x minus 5. And then that is your final answer for factoring by grouping. Factor x squared plus x minus 6. Factor the trinomial. So there's a lot of ways to factor, but I'm going to show you the way that I factor, and I find it the easiest. So, and this is a good simple one to start with. So you have a trinomial. The signs matter, and there's a pattern to doing it that can be foolproof. Okay, so first we want to set it up. When you factor a trinomial, you're going to have two binomials. Look at your leading term is x squared. Your leading coefficient is a 1. So for these, it's easy to set it up. The first two terms are going to just be x and x, whatever the variables are. Now, what you want to do, drop the first sign, whatever it is, okay? Then the second sign is going to be when you multiply these two. Positive times negative is negative. So this is going to be negative. All right? So again, we dropped the first sign and then multiply the signs together to get the next sign. All right, so now you need two numbers that will multiply to give you your C or 6, and then will subtract to give you your B. Now here's something. If your C, and when I'm talking about C, this is x squared plus bx plus c. So we need two numbers that will multiply to give me 6, okay, and subtract to give me 1, this coefficient here. Why subtract? Because my 6 is negative. So what are two numbers? So 3 and 2. And let me just list out my factors. So we have 6 times 1 is 6, 3 times 2 is 6, and that's it. So I need a combo that's going to help me get to 1. So 3 and 2 is going to be my combo. Now, I'm going to put the bigger number first. If I follow my sign pattern, like I showed you here, where I drop the first sign and then multiply it to get the next sign, I want to put the bigger factor first. So the bigger factor between 3 and 2 is 3, so the 3 will go there, and the 2 will go there. And so I need two numbers that will multiply to give me the 6, and subtract to give me 1, and that would be 3 and 2, because 3 minus 2 is 1. And so this is my factored answer here. And how can you check yourself? You can check any factoring by multiplying it back together. Okay? So you can just distribute to see if you get your original polynomial. So x squared minus 2x plus 3x minus 6. Combine like terms, and you have x squared plus x minus 6. So we do have the right answer there. Factor 5x squared plus 7x minus 6. So we don't have a leading coefficient of 1, so we're going to do what I call it bottoms up, or some people call it slide and divide. But we're going to start by getting like a new trinomial, a simpler trinomial to work with. So we're going to drop the x squared, keep my plus 7x, but the number that goes here is going to be by multiplying a times c. So 5 times negative 6 is negative 30. Now I'm going to use my simpler trinomial to help me factor this original one. So I'm going to start off with x and x. Again, I'm going to bring down my sign and then multiply to get the next sign. So it's going to be x plus and x minus. Now, I need two numbers that will multiply together to give me 30 and subtract, because this is negative, to give me 7. So let me list my factors for 30. 1 times 30 is 30. 3 times 10 is 30. 5 times 6 is 30. 2 times 15 is 30. I think that's it. So between these pairs, which, if I subtract the difference, will give me 7. That would be this guy here, 3 and 10. I'm going to put the bigger factor first, which is 10, and then put the other factor here, which is 3. So again, I need two numbers that multiply to give me 30, and subtract, because it's negative, 30 to give me 7. And that was 10 minus 3. Now, I'm not done, because remember, I created a simpler trinomial, like a trial trinomial, to help me factor the original guy here. So I gotta take this 5 here, and I have to divide by that 5, and now I'm going to do the bottoms up or the slide divide part. So if you divide and then simplify wherever you can, and if you still have a fraction, you do bottoms up. So for example, 10 divided by 5 is 2. You can't, that's it. So my first part of my factor form, which is x plus 2, because 10 divided by 5 is 2. Now for the next one, 3 divided by 5. I can't simplify that further or reduce it further. So here I'm going to do bottoms up or slide and divide. So that's going to be times 5x minus 3. I'm literally taking the 5, bringing it up, and then just as my coefficient for my factor. And this is actually my final answer here. And how can you check yourself? You can always just go back and multiply through to see if you get your original polynomial. Factor 25y squared minus 64. So it's 2 terms, so it's either the difference of squares or the difference of cubes. This is y squared, so it is likely a squared minus b squared, difference of squares. And that's just going to be a plus b times a minus b. So just like the other factor pattern, you have to figure out what your a and your b is, and then plug it into your pattern. So we're going to just basically take the square root of both of these to figure out what is my a and what is my b. So the square root of 25y squared is 5y. And the square root of 64 is 8. So this is actually 5y squared minus 8 squared. So then your a is 5y and your b is 8. So everywhere you see a, you write 5y. Everywhere you see b, you write 8. So that's going to be 5y plus 8 times 5y minus 8. And that is going to be your final answer there. Okay, so solve the application using a system of linear equations. Do we have to use the a? Well, the formula is a plus b times a minus b. And yes, if you are factoring a difference of squares problem, then you need to know that factor pattern. You need to know all of the factor patterns, a squared minus b squared, and then a cubed plus b cubed, or a cubed minus b cubed. You need to know all 3 of those for your test. Okay, so let's solve this word problem. So Marcus earned $8,100 during his summer vacation. He invested part of the money at 10% and the rest at 6%. If he received a total of $610 in interest at the end of the year, how much was invested at each rate? So it's talking about interest. So you're going to need to be familiar with the interest formula, which is I equals PRT. Some people call that PERT, the PERT formula. So I is your amount in interest. We'll put the amount, not the rate, okay? P is your principal, or the amount that you are investing, your starting amount. R is the rate, it's the percent, and then T is time. Okay, so let's see. So we're going to compare 2 different things. So he invests his money in 2 separate accounts. Okay, so one account is at a 10% interest, and the other account is at a 6% interest. So we're going to use a table to start to organize this. So I'm going to say account 1, account 2. Our principal amount for each account, the rate for each account, the time that it was invested for each account, and then the interest amount for each account. Okay? So let's fill some of this information in. So if he received a total of $610 in interest at the end of the year, how much was invested? So the principal is asking you, that's how much you invested, your investment. So you're looking for the principal for each account. That's what this is asking. So I'm going to make one account, let that variable be X, and the other account, the variable will be Y. And what's the total amount? Make this total. What's the total amount that he had to invest? That was $8,100. So that's everything we know about his principal amount, which is the amount he has to invest. Okay, the rates. So what's the rates for each one? So the rate for account 1, which I'm using yellow to highlight, was at 10%. The rate for the second account was at 6%. Okay, now how much time went by for the investment? 1 year. So time would be 1 and 1. So interest equals principal times rate times time. Well, we have a principal, X, we have a rate, 10%, and we have a time. So notice when you are multiplying these values into the formula, you always want to change the the percent to a decimal. So this is going to actually be 10% is 0.10. So this interest, expression would be P times R times T, which would be X times 0.10 times 1, which is just 0.10x. I equals P times R times T. So we did P times R times T to get our value here. And then the same thing for the second account. P, which is Y, times the rate, which is going to be 0.06, times the time, which is 1, going to be 0.06y. And now, what was the total amount that he received after his in interest? That was 610. That was the total amount that he received. So that's going to be the amount we put here. So we actually have enough information to write 2 different equations. So we've got this information here and this information here. X plus Y equals 8100. And then we have 0.10x plus 0.06y equals 610. So now we're going to solve this by using whatever method we want. I'm going to probably use substitution. Okay, so I'm going to solve for x. X equals 8100 minus y. So I'm going to take this 8100 minus y and plug in for x into the other equation. I'm going to distribute the 0.10. 810 minus 0.10y plus 0.06y equals 610. I'm going to combine like terms. 810 minus 0.04y equals 610. Subtract 810 from both sides. So I have negative 0.04y equals negative 200, and divide by negative 0.04, y equals 5,000. So I have y equals 5,000. I need to get my x. So remember I said x plus y equals 8100. If I plug in my 5,000 for y, x plus 5,000 equals 8100. Subtract 5,000, and x equals 3,100. So how much was invested at each rate? So for the first account, $3,100 was invested in the first account. How much was invested at the second account at 6%? $5,000. Question 15, we're going to solve by clearing fractions. 1/4 x minus 1/6 y is 1, and 1/7 x minus y equals 6. And we're going to solve by clearing fractions. So I need an LCD for the first equation. That would be 12. Okay? So if I multiply everything by 12, let's see what happens. 12 times 1/4 x minus 12 times 1/6 y equals 12 times 1. Okay, so that ends up being 12 times 1/4 is 3x minus 12 times 1/6, 2y equals 12 times 1, which is 12. Look how pretty the equation is. Now let's do the second one. So what number can I multiply everything by in the second equation to get rid of the fraction? Well, that's an easier one. It's just 7, because that's the only denominator we have. So when we do that, we have 7 times 1/7x minus 7 times y equals 7 times 6. So then we're going to have 7 times 1/7 is just x minus 7y equals 7 times 6, which is 42. So let me take my new equations, my new and improved equations, and write them together so we can see it better. So we have 3x minus 2y equals 12, and x minus 7y equals 42. So now we need to solve the system. Just to get you guys' input, which method do you want me to use? Substitution or elimination? Because you can totally use either one just as well. So I want you to tell me what you want me to use. Substitution or elimination? Whoever says it first. Substitution, that's the winner. Okay. Oh, shoot, the battery's low. Let me run and grab my charger. Okay. Let's do substitution. So if we're going to use substitution, do you think we should work with the first equation or the second equation? You could do either one, but one of them is easier. First equation or second equation? Awesome. Second equation. And solve for which variable, x or y. Which one would be easier to get isolated by itself? The x or the y? Definitely the second one would be the one I would use. So I would choose x to solve for. Awesome. Perfect. Because you only have to do one thing. So if we take the second equation, all you have to do is add 7y to both sides. So then we'll have x equals 7y plus 42. And then we would take 7y plus 42 and plug it in for x in the other equation. So that would be 3 times 7y plus 42 minus 2y equals 12. Then I would distribute the 3. 3 times 7y is 21y. 3 times 42 is 126. Bring down that minus 2y equals 12. And then I'm going to combine like terms. So 21y minus 2y is 19y plus 126 equals 12. Subtract 126. So 19y equals negative 114, and divide that by 19, and I'm going to have y equals negative 6. So that is half of my solution. I need to get the other half by plugging it back into one of my equations. I'm going to use this guy here because it's already set up nicely for us. So x equals 7y plus 42. Let's plug in -6 in for y and see what we get for x. So I'm going to, x equals 7 times -6, -42 plus 42. So x equals 0. All right, cool. So that's the other half of my solution. So my solution is going to be 0, comma, -6. Because remember, it's x, comma, y. And that is my solution. Solve the application using a system of linear equations. So 31,000 people attended a ball game at a stadium that offers two kinds of seats, general admission and reserved. So we're going to say that X is for general admission and Y is for reserved. The day's receipts were $249,000. How many people paid $13 for reserved seats? And how many paid $6 for general admission? So X represents the number of general admission tickets, and Y represents the number of reserved tickets. So if 31,000 people attended, then X plus Y equals 31,000. Now, if the receipts were 249,000, then if you paid $13 for a reserved seat and $6 for general admission, 6 times X plus 13 times Y should equal 249,000. And then from there, you're going to solve this system. So we can use substitution if we want. So I'm going to use elimination just to practice it. So I'm going to eliminate the x values. So I'm going to multiply the first equation by -6. So then I'm going to have -6x, if I distribute, -6y, and then -6 times 31,000 is going to be -186,000. So now when I add those equations, 6x plus -6x cancels, 13y minus 6y is going to be 7y, and then 249,000 minus 186,000 is 63,000. I'm going to divide both sides by 7. So y equals 9,000. And now to get, because that's the number of reserved seats. And then now to get x, remember I said that x plus y equals 31,000. So if I plug in my 9,000 for y, then I will be able to solve my x variable. So x equals 31,000 minus 9,000, which is 22,000. So we had 22,000 people paid $6 for general admission, and then 9,000 people paid $13 for reserved seats. Please feel free to contact me throughout the week if you have questions. So again, you have from now until Monday to take test 2. Again, do the review multiple times. The more comfortable you are with the review, the better you will do at the actual test. Email me, give me a call, come stop by the depot. We've got lots of resources. You guys will do great. Remember, you can go to any Valencia testing center. Please pay attention to the days and hours of operation at each testing center. I am more familiar with Osceola's because this is where I am, but you can use any testing center. So thank you guys so much. I hope you have a wonderful Tuesday, and I will talk to you later.